Okay. Hi, everyone. Again, welcome to the second webinar. Thank you to those who were here for the first webinar. Thank you to those who are joining us for the first time. So today we'll be talking about some of the tools and techniques that help us to be successful math and science students. And so the show broadly is going to be divided into a couple categories. We are going to start with something very basic as screen readers. Pretty much all of us know about screen readers. And then we're going to go into detail about specifically math and science. So talking about how to read mathematics and science, how to write mathematics and science, and then we'll be going into how do you do lab work, how do you do graphs, for example. Then rough work or scratch work is a crucial component of math and science as well. So we'll also be spending some time talking about how do we do that. And we're going to end with some perspective on how do blind developers code. And so that's going to be another interesting thing that we're talking about. Finally, we're also going to talk a little bit about some of the challenges that people face while doing math and science. So while there are technologies available, there are still some things that need to be done, still some progress that needs to be made. So we'll be ending the show with a bit on that and ways for you to get involved in trying to make this space more accessible with iSTEM. That's going to be essentially the broad outline of the show today. So yeah, thank you so much again for joining us, and we'll get started. To get us started, I'll ask Venkatesh to briefly talk about screen readers. I know most of us know about it, but just to make it comprehensive and just to make sure that everyone is on the same page, actually going to start with a brief introduction to screen readers. Venkatesh.
Uh, yeah, Venkatesh, just
Yeah,
before you start, Karthik, can you
yeah,
announce about the
Oh,
presentation?
sorry. Yeah. So for those of you who are cited here, we are sharing a presentation. Can someone confirm if they can see the presentation just to make sure? Is there anyone who can see the presentation? Okay, awesome. All right, so presentation can be seen. For those of you who are blind,
Yes.
awesome, thank you. Um, for those of you who are blind, you can actually refer to the presentation at the same time as well. If you go to our website, inclusivestem.org/webinar2.pptx, that's inclusivestem.org/webinar2.pptx. You can actually download the presentation and review it at the same time as others. So I'll give like about 30 seconds or about 40 seconds to anyone to go and like pull up the presentation so that they're on the same page so it doesn't really get started. So about 30, 40 seconds. Okay, awesome. Venkatesh, can you get us started?
sure. Thank you so much, Karthik. Hello, everyone. So I just thought we'll take a step back and talk about how visually impaired people use computers. Right? So visually impaired people use software called screen readers to access computers. So these screen readers are software which convert text that is displayed or text that is selected on screen or text that is typed into speech. That is, whatever is there on screen, whatever is selected or whatever is typed will be spoken out to a person to be able to hear that. So to give you a few examples, there are a few screen readers for different operating systems. For Windows, you have JAWS for Windows, which is a commercial software by a company called Freedom Scientific. There is NVDA, that is Non-Visual Desktop Access. That's an open source screen reader for Windows. And you have Narrator, that's a built-in screen reader that Microsoft ships with Windows. In Linux, you have a screen reader called Orca. And in Mac and iOS operating systems, you have a screen reader called VoiceOver. In Android, there is a built-in screen reader again called TalkBack. So that's a very, very quick overview about screen readers. And Karthik will take you through the rest of the session.
Awesome. Thanks, Venkatesh. So I'm going to get us started with with kind of talking about reading mathematics. Now, one of the things that works really well with screen readers, as Venkatesh talked about, is reading plain text. So let's say I have a Word document that contains a lot of just like English text essentially, or even Hindi text, for example. That is something that screen readers today are able to read properly, and there are no issues at all. But when it comes to math and science content, that becomes challenging. And there are several reasons that lead to these problems. So the first problem that we have primarily is the fact that mathematics and science, the way it's written, is actually not a linear. It's actually it's actually pretty spatial, right? So think about it. Let's say you have a fraction, right? 2/5 or 2/5. Then the way this is actually written in print is essentially in a spatial way. It's not just like 2/5 that a screen reader will be able to pick up, or 2/5. So how do we make sure that the mathematics that is inaccessible, for example, or that is written in specific formats can actually be read by a screen reader? So we actually need some specific tools that will help us do this. And the first tool that I'm going to talk about is Math Player by Design Science. So what Math Player essentially does is it essentially makes equations accessible with screen reader by providing the semantic information in these equations. And what I mean by that is, for example, it's going to convey, oh, whether it's a fraction, in which case, what is the numerator? What is the denominator? Let's say it's a matrix, then it's supposed to convey to me, for example, oh, this matrix contains so many rows and so many columns. Um, by the way, I think I can hear myself. I'm gonna make sure. Correct. Yeah. So that, for example, is one thing that MathPlayer can do. MathPlayer is essentially this add-on that you will need to install from Design Science website. It's a free add-on. And what happens then is if you have content in a particular format, in this case, if you have content in math markup language or MathML, then this content actually can be read out by JAWS in browsers such as Internet Explorer. So this is a very common tool that is often used if you have mathematics in accessible format. So NVDA, which is the screen reader that Venkatesh talked about briefly before, this screen reader also it allows you to essentially use the mathematics mode. So you can see on the slides, there's a command called NVDA key plus Alt plus M that helps you go into the math mode, and then you can use the arrow keys or the direction keys to navigate any mathematical equations. So this capability is also inbuilt or is provided by NVDA, including in Office. So this is again another tool screen reader that you can use to do math. Next tool is MathML. This is by MathJax Consortium. So we just talked about MathML and how this is a specific language that is used for writing mathematics that renders it accessible. But the problem with Math Player, which is one of the tools that we use to make this accessible and this kind of readable by a screen reader, is that it works with very specific browsers. So for example, it only works with Internet Explorer. So the good part about MathJax is that it is independent of the browser that you're using. So in terms of platform and browser compatibility, this actually supports much more than what is supported by MathPlayer. So if you're looking for reader compatibility, then this is the software that you should be looking at. The next software is InfiniReader by Infinity Project, which is a project in Japan. Now, we so far have been talking about what do we do if we have mathematics available in accessible format as accessible electronic text, right? And we were talking about how we can use these specific software for these specific formats. Now, what happens if mathematics is actually available as a printed document? How do we take that document and how do we read that mathematics? That is what a specific OCR software or optical character recognition that many of us commonly also just call scanning, essentially. This is what we use for. So might be many of us who are familiar with software such as Fine Reader or Kurzweil, which are these scanning tools that many of us use in our daily lives for scanning things like just regular English textbooks. Now, these tools do not work very well with any of the mathematics or science documents. So what we want to do if you want to be able to convert these tools is actually use specific software, such as the Infy reader that I'm talking about right now. Um, so it provides pretty good accuracy. And there's a specific format, which is known as the IML format, which is this custom format that Chatty Infy uses, and we'll get to what Chatty Infy is in a bit. But essentially, it's the sister organization for, or just a software for Chatty Infy. So the only problem with the software is the cost. So the software, as of now, costs around $400 US, which makes it sort of an impediment for us to buy it in India right now. So this is the big kind of challenge that comes with Infy, but it is available if you were to do OCR. Finally, let's talk about JAWS Dictionary Manager. And I would start off with a disclaimer that this is particularly useful for those of you who are using older versions of JAWS. So let's say you're using JAWS 16 and below. Then what happens sometimes is that JAWS can actually not read out all of the mathematical symbols. So how do we do that? We can use JAWS Dictionary Manager, where what it essentially does is it takes in a symbol notation. For example, it'll take in alpha or beta or one of those other symbols, and you have the ability of replacing this instance of the symbol notation with the actual word or string that you want this to be replaced with. So for example, you could actually say, okay, if I have like the notation alpha, then make sure that every time when you're reading out my content, you replace it with ALPHA, or alpha spelled out, so that even if screen reader cannot pick up on alpha notation, it can actually pick up on that word ALPHA and can read that out to you. So that now you essentially have alpha spoken out to you when you're reading mathematics. And this is particularly useful if you're not using one of those technical fancy ways of reading mathematics that I talked about briefly, such as MathML, or if you're not writing it in LaTeX, and if you're actually just using a simple word processor, such as Microsoft Word, to write your mathematics and science, then you can take advantage of the JAWS Dictionary Manager to ensure that you can actually hear all of the symbols. Again, in latest versions of JAWS, this comes by default. JAWS is able to read pretty much all of the symbols from the get-go. So that's pretty much it for reading mathematics, and I'm going to pass it on now to Akashdeep, who's going to talk about writing mathematics.
Thank you, Karthik. It's you very well described. Or I can use a MathML. MathML is pretty accessible, but it's not a...
One sec, Akashdeep, please. Sorry, my bad. I'm going to mute everyone. Can you please unmute yourself?
Okay.
All right, awesome.
Okay, so basically we have three types of scripts. We can use ASCII math, we can use LaTeX, or we can use a MathML. So MathML is a pretty accessible format, but it's not a good way to write directly. So what we generally use, either we write in the ASCII or we use LaTeX conventions, LaTeX scripts to write the mathematics, and then we convert it to the MathML. So basically ASCII math is just like basically writing in a using your keyboard symbols. Like if you want to write fractions, so you use the backslash, slash key, /. So the normal convention which we used to follow in the normal writing, that's the convention which we write in the ASCII. Another is the LaTeX. LaTeX is another script which we use, in which what we do is, for writing the mathematical symbols, we have a convention like we press the backslash key and then write the name of the symbol using the alphanumeric keyboard. So like I want to write the alpha, so I will press backslash and then I will write ALPHA. So, and this is the convention which I can use for writing any kind of symbol. So whatever the symbol is, just backslash and the symbol. So these are the conventions. So with these, we have a tool named as a math type, which is again from the design science, which is an add-on for the MS Office. This also has an editor, but editor is not accessible. But still in the MS Word, you can write the equations in the form of the LaTeX, and then using the Alt plus backslash key, you can convert it to the visual notations, and which you can read with the help of the math player, which already described by Karthik. Another tool is ChatInfty, which is again from the Infty project from Japan. It has a accessible editor, which basically again use the LaTeX, or also provides an option to insert symbol. That's also accessible. It also has its own voice output. What's the difference between the MathType and the ChatInfty is ChatInfty basically doesn't ask you to write the whole LaTeX convention. It just, if you write a symbol in the LaTeX convention and then just you press the spacebar, it automatically get converted into the cited notations. So you doesn't need to take care of all the parentheses and everything, which is a big hassle while you are writing with the LaTeX. Again, it's the big impairment with it is, again, its cost. It's cost around $200. So again, it's a big challenge for developing countries like India. Means for a student in developing countries like India, so how to afford it. Another tool is, okay, so auto text is basically a feature which MS Word has. By using that feature, what you can do is you can convert any text string into some other format. So for writing the mathematics, what we can do is we can define our own conventions using, it has a shortcut, Alt plus F3, by which you can define your own conventions, that if I write SUM, so and press the F3 key, it will automatically get converted into the summation symbol. So this is sort of like a hack, which someone can use in the MS Word using the auto text feature. So now this is what all we have about the writing mathematics. Now I would like to pass it on to Sunil for describing how we can manage the graphics.
Thank you, Akashi. Now let us move towards how to access graphical or diagrammatic information. Basically, we have three modes to do this. One is sonification, or using sound clues. Second is textual mode, or using touch to get the information. And third is textual mode, or text about the graph. So firstly, in first sonification mode, what basically happens is that the graph is converted into sound. So the monotonicity of graph is described by the sound pitch. For example, the pitch changes from high to low when the y coordinate of graph changes from up to low value. And similarly, for describing left and right position, we can use panning, that basically the left half of the graph is heard in your left ear, and similarly right half is heard in your right ear. So there are tools like audiographing calculator and MathTrex that use this principle. So MathTrex is basically a free software by NASA that provides you this sound information as well as textual information about the graph that you are inputting into it. So you can read this textual information in the window of MathTrex. Secondly, coming to the textual mode or touch, we have a device basically known as glue gun, which is, what it does is that it basically used to stick to hard surfaces. So it uses cylindrical sticks, which are known as hot melt adhesives, and these melt adhesives or HMAs are loaded into the gun and then sprayed onto a paper into the desired form shape of the graph that we want. And then this information can be accessed by the user when it's solidified, maybe after a few minutes. That a person can touch the graph and learn the information about the graph. And then what we have is a chem access tool, which basically gives you a textual information or text about the chemical molecules. And similarly, there is one more tool named as Braille, developed by Jonathan Godfrey. What it does is that it converts the graph into the textual format, and basically it is used for dealing with statistics. And again, these tools are there, but when as the graph becomes more and more complex, they pose some challenges while in understanding the graph. With this, I would like to ask uh, Paras to explain how can we handle lab works.
Thank you, Sunil. It was nice hearing about graphs and all from you. So, managing labs that can be done in two aspects. One is the non-technical, and another is the technical. First, I'll be talking about the non-technical part where we can make modification and adjustments by tactile labeling on the apparatus, beakers, and stuff. Other aspect is like can perform experiment by relying solely on the non-visual factors like smell in case of sulfur, etc., and the pop sound of hydrogen. And if we talk about the technical aspects in lab, uh, there's talking Labquest, which basically adds sensors, talking sensor to the existing sensors, and it comes with a USB keyboard and that stainless steel temperature, differential voltage, and current. Additional sensors are also available on demand. So this way, lab work can be very easily managed. I'll ask Abhisar to tell us about performing rough work.
Before Abhisar continues, I'd like to just briefly talk a little bit more about LabQuest, since that might be of some of interest to people. So LabQuest, the problem again is the cost. It's pretty expensive as it stands right now. It's 2,000 US dollars. That's a problem. However, a few institutes in the country have LabQuest, where essentially, as Paras mentioned, it just takes in any sort of you can essentially think of it as any vernier apparatus. Vernier is this company that manufactures a lot of laboratory equipment. You can take any of that and you can convert that into a talking sensor. Essentially, all that it really does is it interfaces with this apparatus and just like gathers all of the information from the apparatus and converts that into audio that you can then understand. And you can navigate using a screen reader, and you can also actually navigate visual content. For example, let's say you wanted to plot continuously like the observations that a particular apparatus is making, then you can actually hear various information about that, such as what is a mean, what is a median, so all basically statistical information about it, as well as, of course, if there are any anomalies that you should be aware of. So this is what LabQuest helps you do. Abhisar, over to you.
Thank you, Paras and Karthik. It was really a great information. So, guys, let's now move on to our next part, that is rough and scratch work. Basically, here we will be like I'll be dealing with things like how we can stop scratching our heads. So, let's move on to our first thing. We have tailor frame in our hand. So what actually a tailor frame is? I would like to give one advance note to our listeners. Um we are not limited to these tools for our rough works. Definitely, other people have their own sort of rough work and scratch work techniques. So, it's not like we are limited to these things. And also there are few challenges with this which we'll be discussing later. So and also these tools, few of the tools which I'll be describing, they are a little bit, they can be a little bit difficult explaining virtually. So my apologies in advance. So let's start. Starting with the Taylor frame, it's actually a kind of rectangular frame which consists of star-shaped, eight-angled holes and metal types, which in which the metal types are actually small, like metal rods, which you can attach it over the holes in a particular orientation just to form kind of a number kind of structure or something. And and through this then orientations, we can, like, by forming these numbers, we can then use these things for simple calculations like addition, subtraction, multiplication, and division stuffs. And like, this is just basic Taylor frame, very easy to handle, very easy to use. Now let's move on to our next Scratchwork plot, that is a spreadsheet. Many of us might be aware of Microsoft Excel and Google Spreadsheet. These are nothing but a row and column orientation of cells. Where by row I mean the horizontal alignment of cells, and by column I mean the vertical alignment of cells. It is a basically combination of vertical and horizontal alignment of cells, that is rows and columns. How we can use this for our scratch work? The each and every cell of this spreadsheet can be used to input a number. Let's just say we have to add uh, 12 plus 34. So what we can do is, uh, in one of the cell we can input 1. In the cell right beside it we can input 2. In the cell below 1 and 2 we can insert 3 and 4 respectively. Here we can very easily access the numbers 1, 2, 3, and 4. So now here we can see the number 4 is just right below the number 2. So we can add it up and we can get the number 6, and which we can write just below the 4. And moving over to the left side we have 1, below which it is the number 2, and below which there is the number 3. Adding that up we will get 4. Here we have basically got our answer as 46, which is the right answer. This is just a very simple way of doing this. One more way which we can do this is by we can use each and every cell of this spreadsheet for calculation stuff. So how this can be done is, you can just simply write in cell you can write equal to, and then you can let's just say I'll take the example again, 12 plus 34. So what we can do is equal to 12 plus the sign of plus equal to the 12 plus 34, and as soon as we press the enter we'll get the answer as 46 right in that same cell. Even though we won't be able to access what we wrote for the addition, but we'll have the final answer here. So this is how you can use a spreadsheet. Moving on to our next thing, we have the VP Arithmetic. So this is a kind of software which is our spreadsheet kind of thing. But the major advantage what we have here is it gives us feedback. Things like addition, subtraction, multiplication, division, and all those stuff. This can also be done here. Advantage, the main beneficiaries of this VP Arithmetic can be the elementary and middle class students who want to learn different aspects of arithmetic calculations, so they can get benefited by this. What actually happens here is, it is like the similar way as we did in the spreadsheet. We can add up 1 2 3 4, putting up in the columns. And let's just say by any means the person does anything wrong, like he adds up 2 plus 4 as 7. So we'll get a feedback that, oh, this is the addition, what you did is wrong. So this tool is very helpful for mainly for the elementary and middle class students. They can do a great practice through this. So this is about the VP Arithmetic. Now moving on to our next thing, we have Abacus. And trust me, Abacus is still very famous. Many of the cited Chinese people, they are still very fond of Abacus, using it for calculations and all the stuff. So what actually Abacus is? Abacus is basically, it is a kind of a rectangular frame which you can like imagine, which is divided into two halves. So in the lower half we have vertical strings, and every string has 4 bits in it, and in the upper half, there also we have vertical strings arranged in the sort of columns kind of thing. But in the upper half, we have only one bit in every string. So let's just say I want to represent a number 7. So what we can do is the lower half of the lower part of the abacus, we'll start it from the right hand side. We always start it from the right hand side for our convenience. So starting from the right hand side, we have 4 beads in the lower half. So we can pull up the 2 beads from the lower half, which will make it the number 2, and from the upper half the 1 bead. So basically the upper half bead represents the number 5. So when we pull down the single bead from the upper half, it represents the number 5. So basically in the rightmost column, what we have is number 5 and number 2. So adding both them up, we get the number 7. And let's just say now we want to do addition 10. So what we can simply do is just towards the left side of the first column, the upper half column, the upper bead in the upper half column, we can just pull it down. So which makes it the second string. So we can pull the single bead from the second string, which will make it 10. So basically 10 plus 5 plus 2, we get 17. So this is just simple calculation which we can do through abacus. And I mean, obviously we can definitely do many more stuffs over the abacus. Yeah, definitely we have some challenges here. It would be difficult for us to remember many of the previously done scratch work, as like sighted people they make notes. But in few of the tools here we might not be able to do this. And there are few of the challenges which my friend Venkatesh will be discussing in his further talk. Now I request Venkatesh to tell you guys more about integrated development environments. Over to you, Venkatesh.
Thank you, Abhisar. Yeah, hello everyone. So I'll be briefly talking about programming tools and how do visually impaired developers go about writing code. So the first thing that I'll be talking about is the command line interfaces. So what this essentially is uh, all the operating systems like Windows and Linux and Mac, they have a command line. That is, you can operate the computer with a through commands, text-based commands, and even the output is also text-based. So some visually impaired developers use command line tools to write code. So they use a text editor like Notepad or whatever they're comfortable with to write code, and they use the command line interface, that is the console in Windows and in the terminal in Linux or Mac, to run the commands that would build and compile their code. So the thing is, the inherent nature of the command line interface is being text. Screen readers are able to read out the output, and also visually impaired developers are able to give the input to the command line interface. So when there is large amount of outputs that's to be read, developers also have other strategies, like they redirect the output into the clipboard. So instead of printing the output on the screen, the output gets copied onto the clipboard. Then they go to the notepad, they paste it, and they can go through the output like any other text. But yeah, that said, there are tools that sighted developers use which simplify the programming process by a great deal. And those are called IDEs, or integrated development environments. So visually impaired developers also use IDEs with screen readers. Like, for instance, there are a few IDEs that are very accessible. So Microsoft's Visual Studio is a very good example of an accessible IDE, where it supports C#, Python, a whole different set of languages, and it has extensions and so on. Dev C++ is another IDE that visually impaired developers, a lot of visually impaired developers use to write C++ code, and Code Blocks is another such IDE. So these are a few IDEs, and as I also mentioned, right, they have accessibility features, but despite the built-in accessibility features, there's more information that is to be conveyed to screen reader user, because a lot of information that these IDEs convey is very visual. For instance, when you have an error, you have a red colored visual indicator stating that you have an error, and so on. So there are also other extensions that are being developed to basically improve the accessibility of IDEs. And I'll give you one example of such an extension called CodeTalk. So CodeTalk is, sorry, yeah, CodeTalk is actually a plugin that currently runs on Visual Studio. It supports C# and Python. So this IDE plugin improves the accessibility in certain ways. Just let me give you a few examples. So a lot of times when you're looking at a code file, right, let's say there's a code file, you'll have 1,000 lines of code or 500 lines of code. And you would want to know the structure of the code file. So how is it organized? What are the classes, functions, and so on? These are all programming paradigms, programming constructs. So a lot of times what happens is a visually impaired developer would have to go through these things one line at a time. But with CodeTalk, one of the functionality that we have brings about accessible code summary tree view, so that a visually impaired developer gets the outline structure of the code, so they can understand the different classes, functions, and so on, the structure of the open code file without having to go through the code one line at a time. Similarly, we have features to indicate visually impaired developers to errors. Because one example I just gave you is when there is an error, there's a red squiggle that shows up, which if somebody is looking at the screen, indicates to the user that there's an error. So what CodeTalk does is it plays a tone when a developer makes an error. So you have other functionality within the plugin itself, which will list all the errors to you so that you can go ahead and fix them. Without this kind of information, a lot of visually impaired developers have actually build code and then look for errors, fix them, and repeat this process. Debugging is a very important component in programming. That is, you find logical or other issues in your code. So your code runs, everything looks fine, but the result is not as you expect in some cases. So we also have improvements with debugging, where there are audio debugging that happens. For instance, you can have specific tones played when your code is executing. So this essentially helps you figure out what block of code you are executing. For instance, sometimes you're only interested in whether you're in the if block or an else block, and so on. So you can just place these audio breakpoints, listen to the tones, and understand how the code is being executed. Similarly, you can also have values of variables being announced as they are executing. For instance, let's say you have a loop. You want to know how the loop counter is increased. So you can have an audio breakpoint which will actually speak out the loop counter at specific points in code. These are just a few ways in which CodeTalk helps developers, and also IDEs themselves are very accessible. So if you really want to get into programming, you can actually try Visual Studio Code, which is a free one, or Visual Studio Community Edition, or even Dev C++. And if you want to try CodeTalk, it's available online. It's open source. It's free of cost. Right? Also, though there are all these tools, programming still has its own set of challenges. Like, as I said, still the information is very inherently visual in nature, and conveying this in a non-visual way is a huge challenge, and there is active work going on in that space. Let me actually take a step back and talk about the challenges in general, which are pertaining to math and science content access. So, till now, you've actually heard about the different approaches, techniques, and strategies that visually impaired students can use to read math, write math, graphs, and so on, right? But they have their own set of challenges, and the first one that I'm going to talk about is the learning curve. So there are all these different tools that are available, but though they improve the functionality, there's a huge learning curve that is involved with actually getting up to speed with them. And as you've heard before, some of them are fairly expensive right? To the amount of $400, $200. It's not very affordable. And there is also some ambiguity still exists in spoken math. Like, how do you speak a mathematical expression so that the meaning gets conveyed properly, right? For instance, if you say something like e power x plus 1, you wouldn't know it if it's e power x and there's a plus 1, or it's the whole thing is raised to x plus 1. So proper way of speaking math is also a challenge. And there's also a cognitive overload that is involved with using some of these tools. And as Abhisar also just briefly mentioned, persistence of the content that you create in some of these tools is a huge issue. Like, let's say you want to do some scratch work and you want to refer back to it later, or you want to uh, uh, refer back to some of the things that you do, right? There's no good way of storing the content so that you can get back to it when you're using some of these tools. And yeah, there is definitely these challenges, and there is scope for improvement. And now I'll hand it to Karthik to walk you through the rest of the
Awesome. Thanks, Venkatesh. That was a really good description. So yeah, as Venkatesh mentioned, again, a lot of tools available, but there are still challenges, and that is precisely what iSTEM is trying to do, especially through our research projects, where the idea is, for example, how can we make navigation of mathematical documents easier? Let's say, for example, if you have a huge file with like thousand equations, then how is it possible or like better for someone to navigate this document and understand and find for whatever they're looking with a screen reader? That becomes a pretty daunting task. So there are things like that that ISTEM is currently focusing on. And again, as always, we invite you to join the community. You can always go to inclusivestem.org/getinvolved.html. And join the community. You can always send us an email anytime at info@inclusivestem.org, and ask us about any questions that you might have, or just sort of talk about things that you're interested in that potentially we could help with or our community can help with, and definitely happy to chat. So that's pretty much it for this webinar. And I hope that you found some of the tools that we talked about useful. And we wanted to make sure that we have some time at the end to answer these questions. And before I open it to questions, I want to just make this last announcement, which is I know and I completely understand that 40 minutes is certainly not enough to talk about all that we really did today. So this was supposed to be a brief survey of everything that is available. There's more information about these tools also available on our YouTube channel. So you can find that YouTube channel on our website. You can also search on YouTube for iSTEM, and you should be able to find a bunch of videos on math and science accessibility that cover these tools. And you're always happy to answer any questions about these tools as well. We completely understand it's really unfair to basically just like learn about all of this in 40 minutes, but that's the best that we can do right now virtually. So hopefully we'll get a lot of questions from you and we'll be able to answer those questions for you. Um, and so, yeah, we will open it up to questions. So anyone who has any questions, either type it into the chat window or just speak it out loud. Just unmute yourself and ask any question. I'll wait for a bit, otherwise I'll unmute everyone just so you can ask your questions. For anyone who is listening to this in Radio Udon, you can send your questions again to the Radio Udon team. You can send us an email at info@inclusivestem.org, as I just mentioned, and we'll be sure to answer any questions that we receive in the next episode as well, or personally follow up with you as the ISTEM team. So you have all of these options available to you. So yes, open to questions now. Okay, so Arjavi asks us which resources are available to learn programming languages. That's a good question. We don't endorse a particular resource, but on experience, we found, for example, tutorials point to be pretty good. We also have a couple resources that we prepared depending on what is it that you're trying to do, whether it's web development or it's Android development or it's machine learning involving natural language processing or computer vision and stuff like that. We have a bunch of tutorials that ISTEM prepared as part of preparation for our ISTEM hackathon that we did in Bangalore earlier this year. So all of those tutorials are also available. Please reach out to us if you would want to have access. And for those of you who are going to be a part of the ISTEM internship program starting very, very soon, that's precisely what we're also going to do as part of that program as well, which is to point you to resources where you can learn more about these programming languages and different applications of computer science. Any other questions? Don't be shy.
Karthik, did you mention about MOOCs?
Yeah, I think we talked briefly about it. MOOCs, we talked about it last time. MOOCs essentially are these online courses that are also available. So, for example, there's a class from MIT, which is an intro to computer science that uses Python and introduces you to programming fundamentals. So things such as loops, branching, functions, and so on and so forth. And there have been several people in the community who have done this. We work very closely with Vision Aid. Vision Aid uses a bunch of these MOOCs as well. And generally, a lot of our community members are using it. A really, really innovative, nice, and recommended way to brush up on like a lot of the skills. And a lot of these classes are actually very, very accessible as well. So yes, MOOCs is definitely an option that you should be thinking. And we'll hopefully have more information about this as well later, in the webinar series as well, where one of our community members can come and talk more about it. But yes, MOOCs definitely an option. So some examples: Coursera, edX, Khan Academy is also available. Pluralsight is another MOOC where you can learn a lot about, especially about tech and about uh, technical aspects. So yes, please check them out. Let us know how it works for you. Any other questions? I'm going to unmute everyone just in case. Okay, so okay, everyone should be unmuted. Any questions? All right. Looks like there aren't any right now. Well, that's fine. Take your time to maybe listen to this again, watch the videos. We also have a manual on our website which goes over a lot of this. It's about a 30-page report. 30-page report. So please maybe refer to that as well. And if you have any questions, please let us know. Before we end, a little sneak peek into what's going to happen in the next webinar. The next webinar is going to be on the 16th, the live webinar. And of course, it's going to be broadcasted on Radio Udan the next day. And this time, we're going to have IIT Delhi come in and talk about some of the work that they're doing at their Assistech lab, which is their assistive technology lab. Both for making math and science more accessible, but also otherwise. So we hope to see all of you in the next webinar as well. It should be a lot of fun listening to representatives from IIT Delhi talk about the amazing work that they're doing in their labs. So again, thank you so much everyone for tuning in. Really, really appreciate it. And I really hope that you actually found this useful. Yeah, thank you. Restore the C. Leave meeting. Cancel button. Do you want to? I'd like to give. Leave meeting button.